Welcome to this particular lecture, which is on insulated gate bipolar transistor or IGBT. This is another power semiconductor device. So, this IGBT has been developed by combining both power MOSFET and power BJT. So, it takes the advantages of both power MOSFET and power BJT. In power MOSFET, we have seen it has high input impedance. Why? Because the gate is isolated from the channel. Okay, that is why we need to apply very less gate drive in case of the MOSFET or power MOSFET. So that is why it has very high input impedance. Okay, so IGBT takes this feature of the power MOSFET, and it doesn't include any secondary breakdown problem. What is secondary breakdown problem? See, these power BJTs oftentimes these power semiconductor devices, they operate at very high voltage and very high currents, right? So oftentimes it may happen that the current that is flowing through the device, it is not uniform in all the regions. Okay, the current, it gets localized at some particular region to your device. Okay, or the current gets concentrated at some particular regions to your device. So if a current is more at particular regions, so those regions will act as a hotspot. Okay, now if the current is more to a particular region, what will happen? It will create some overheating to those junction, and it will cause the breakdown or damaging of the device. So IGBT is free from this kind of problem. And like BJT, it has low conduction loss. We will see what is this kind of loss, and it can handle very high amount of current, and it follows same input characteristics like power MOSFET and same output characteristics like BJT. Now let us see the symbol. We know this is the MOSFET symbol. This is the N channel enhancement type MOSFET because the arrow is inward. And why enhancement? Because this channel is discrete, it is not continuous. Okay, and there is a gap between this gate terminal and the channel because there is an oxide layer. So this is my N channel MOSFET and this is my BJT, collector base emitter. If we combine these two symbols, we will get the IGBT. So it has three terminals: collector, emitter and gate. Third terminal is the gate. Okay, now this is my N channel MOSFET and this is my PNP transistor. Okay, because IGBT combines both. Okay, so if you combine this one, what we will get? You will get the symbol of IGBT. We have this collector current and we have this emitter current, and this is my input voltage we are applying between the gate and the emitter terminal, which we are calling it as VGE, which is controlling the output current, that is IC, which is flowing between the collector and the emitter terminal. Now if we see the basic construction of this IGBT, what we have a P plus type substrate. P plus type substrate means substrate is heavily doped. What is the doping concentration? Around 10 to the power 19 per centimeter cube. Then above this P plus substrate, we have an N minus region. N minus means it is lightly doped. Doping concentration is around 10 to the power 14 per centimeter cube. Then above that, this is N plus P region. Okay, this is one type of structure, and this is N plus P. This is another type of structure. You may also see like this almost look like the N channel MOSFET. Doesn't it look like the N channel MOSFET? So consider these are the two N channel MOSFET connected parallel on a single chip. Okay, and these N plus and these N plus, they are connected to the emitter terminal through a metal contact. Here also these N plus and these N plus, they are connected to the emitter terminal through a metal contact. Okay, and this emitter terminal is connected to the negative terminal of the battery through the load, and positive terminal of the battery is connected to the P plus type substrate. Okay, this P plus type substrate is called the injection region, because when, let's say, there is a gate terminal here, where we can apply the voltage emitter to gate emitter voltage. Okay, now this gate terminal is separated from this N minus layer through this oxide, silicon dioxide. This white region is my silicon dioxide. Now first, let's say I haven't given any gate drive, it is 0. Now when you apply this VCC, what will happen? This positive terminal of the battery is connected to the P plus substrate, so it will, the holes are the majority charge carriers, so the holes will get injected into the P plus type substrate. Okay, now next, so that is why we are calling it as injection region. After that we have N minus type region, we are calling it as a drift region. The thickness of this region, it controls the reverse blocking capability of your device. Okay, next we have this N channel MOSFET type structure. This P regions, we are calling it as a body. Okay, now in this condition, what will happen? See, this J1 junction is forward biased, this J2 junction is what? J2 junction is reverse biased, and let's say this is my J3 junction. So J3 junction is again forward biased. Even if you change the polarity of this VCC, what will happen? J1 will be reverse biased, J2 will be reverse biased, and this J3 will be, if we change the polarity of the VCC, what will happen? J1 will be reverse biased, J2 will be forward biased, and J3 will be again reverse biased. Okay, now that means doesn't matter whatever the polarity of this VCC, at any polarity of VCC, when you are not applying any gate drive, one of these junctions are reverse biased. Since due to this reverse bias, no current can flow through this emitter to collector, and no current can flow through the device. Okay, because whenever there is a reverse bias, that means that is open circuit, so the supply cannot reach there. Your circuit is completely disconnected from the rest of the part of your circuitry, so only a little amount of minority carrier current you may get. Okay, now if you apply the positive gate voltage here, what will happen? Positive charge will start getting induced at the gate terminal. Okay, and it will create polarization in this oxide layer. This oxide layer, we have, oxide layer is nothing but an insulator. Okay, so that means it will almost act like a capacitor. So due to this polarization, this capacitor, the top layer of the capacitor, negative charge will get induced, and the bottom layer of the capacitor, positive charge will get induced. And what will happen? In this P type body region, we have the electrons and as the minority charge carrier, so it will attract the electrons near this below this gate terminal. Okay, more you apply the gate voltage, more electrons will get attracted over here, so channel will get formed. Once the channel is formed, what will happen? The current will start flowing like this way and like this way. Okay, that means this N plus region is connected to this N minus region through this channel. Okay, now at each junction we will have some drop or loss. See, at this polarity of this VCC, J1 is forward biased. So at forward biased, what is the voltage drop across PN junction? If we are using the silicon diode, 0.7 volt. Okay, at this junction, this is the 0.7 volt voltage drop. Let's say it is VJ1. Okay, next come to the N minus region. N minus region, let's say the current is flowing IC. So IC multiplied by, there will be some resistance in the N minus channel resistance. Let's say it is RG. So what is the drop or loss here? IC RG. Okay. Now come to this region. What is the drop or loss here? Same IC current is flowing, IC multiplied by, if you consider the channel resistance is RCH, so IC multiplied by RCH. So these are the three on state or conduction losses. Okay. Now in this N minus region, see, from this N plus region it can donate electrons in this region, and from this P plus region it can donate free holes in this region. That means it will create a dual injection in this N minus region, due to which the loss that we have considered in this region, which is IC multiplied by RD, that decreases due to the dual injection. So that is why the on-state conduction loss reduces in this kind of IGBT structure. Okay. And the more you increase the gate voltage, what will happen? The channel resistance will get decreased, because more number of electrons will start getting accumulated here, right? If the channel resistance is decreased, means loss will also be decreased. Okay. So this is the construction of the IGBT. Now if we look at the transfer characteristics of IGBT, then how it will look like? It is almost transfer characteristics means it is the output current versus input voltage. Output current is IC, input voltage is VGE. So when you did not apply any gate drive, what we have seen, channel is not formed, so no current flows to the device. That is why we are not getting any current here. Once you apply the sufficient gate drive, and when it is higher than the threshold voltage, channel is formed, current starts flowing through the device.